In this short video, I want to talk about Java, like a brief history of Java, how it came about, what problem is it solving, and that may help you to decide whether you want to learn Java or you want to learn another language. See, the basic thing is that each language is trying to solve a particular problem. Okay, be it C++, Java, Python, Golang, they are all, they have all been invented to solve a particular problem. So as you will see, as we make progress through this video, you will understand what problem was Java trying to solve. And that will give you some clarity around deciding which language to choose, basically. So I'm not going to do a comparison between these programming languages. I'll do it at some point, but today I'm going to just talk about Java, okay, its history and what it's doing. Okay, so let's start by first of all addressing the basic question: what is Java? It is one of the world's most important and widely used programming language, which has grown stronger with every passing year. So if you see its history, Java started in 90s. Okay, to be precise, I think 95 when it was first announced. And the thing is, at that time, the internet was booming, right? And today it's 2018, and if you see, a lot of market share is held by applications which use Java. Okay, so that goes to say something about the language. It is the language of preference when it comes to developing web-based applications. Most of the enterprises run on Java, like I mentioned. A lot of companies, a lot of web portals, websites, they all use Java under the hood. So that's where the magic is happening. So as computing has advanced, Java has kept pace with it. So with every release, through the years, Java has tried to add features like, be it parallelism, be it concurrency, be it support for the the new features, the current trends. Java has tried to keep pace with the changes. Even with the new version, like I mentioned here, even in the newer version like Java SE9, they have introduced modularity, and the packages within Java framework itself, they are also now organized as modules. Okay, they have also provided JShell, and JShell lets you run short snippet of codes. You don't have to write the entire Java code, but you can write a short snippet and test it out. So they are trying to keep pace with the changes, like what other programming languages are trying to do. They are also trying to uh, uh, keep pace with that, so that as a user of this platform, you don't run away from it. Okay, so how and why Java came about? Let's take a quick look at the history of programming languages. Innovation in language design was driven by the need to solve a fundamental problem. When C was introduced, it had a massive impact. At that time, we didn't had any structured languages. What do I mean by structured languages? If you see the early programming languages, like we all know that initially there was this assembly language, which was very hard to program in, and there were a lot of bugs, defects, and all. So the need for high level programming language was very high, basically. So there were some languages like Fortran and Basic which were introduced, but the problem was they were making use of gotos and all, so they were not structured and very efficient. So C kind of filled this gap. C filled the gap for an efficient, structured, and high level language. So C has its own importance. We all know that most of the like operating systems are written in C. Even compilers are written in C, to make them efficient, basically. So C solved a particular problem, but then the question is, why then C++ came into picture. So what happened is, C was good, no doubt, but as as the software grew in size, it became hard to manage. It grew in complexity, and at the same time, this object-oriented design was picking up. So it's not a new language. It's simply an enhanced version of C. That's why you have plus plus in that. So it added object oriented features to C. Okay, that was one of the problems C++ tried to solve. Now, again, the question is why then Java? When C++ was doing all this, why then Java? So, if you see both these languages, C and C++, there is a problem in these languages. The problem is that these are hardware dependent. I mean, you write a program in C, and then you compile it, and the compiler generates an executable code, right? That is run, that is later run, so that you can get the output and whatever. But the problem is that for every different machine configuration, you have to write a different program in C. Okay, so as a programmer, you are also worried about the hardware details, what kind of processor you are using, what kind of instruction set we are using. So a programming language was needed, which can be platform independent. Okay, so as a programmer, you can write some programs, you can create a software and go ahead and embed it in a electronic device like a microwave oven or some other electronic gadget. Now, while the team at Sun Microsystems was working on this language, suddenly in 90s there was an explosion of World Wide Web and internet. That was gaining popularity, and there was a need for a language which can again be platform independent. So you can write once and run anywhere. And Java actually gained popularity because of this thing. Had it not been internet, I think Java wouldn't have been so popular. But that was one of the primary reasons that Java grew in popularity. And thanks to it, okay, because it's a good language. So Java was invented to solve this problem. I mean, the portability issue. It was conceived by a team at Sun, like I mentioned, and Java, which was originally aimed to solve a small scale problem, which was for embedded software, went on to solve a large scale problem, like the whole World Wide Web thing. So it's not actually an enhanced version of C++, but it's solving a different problem. Okay. So the question is, okay, all this talk is good, like portability and all, but how does Java achieve portability? So let me explain you this with the help of an example. So you write a program in Java, a basic program, and what happens when you compile it? The compiler doesn't produce executable code; it produces byte code. Okay, and this byte code is understood by another virtual machine, which is called Java Virtual Machine. Java Virtual Machine is not like it's not a separate machine. It's just an environment in which this bytecode can get executed. Okay, so now the thing is that compilers are expensive. Like if you are going to have a compiler for each different machine configuration, that is going to cost you. Okay, it's expensive. But when it comes to JVM, it's a far better option. It's a much more efficient option. Okay, so what happens? This bytecode that is generated, uh, it's an optimized set of instructions. Okay, and JVM understands that. So what happens is for every different machine configuration, you can have a separate JVM, and you just have to give the bytecode to that and it'll run it. So as a programmer, you are not worried about, okay, what processor is this machine using, what are the other configurations. You just write up your program and you ship it, your software. As long as the machine has JVM, it'll be taken care of. Okay, so that's what I've written here, the bytecode concept. And bytecode is a highly optimized set of instructions, so on. You don't have to worry about hardware implementation as a programmer, and that's what makes it portable, and it also makes it secure, because see, your program is running in a Java virtual machine, so it can't access other parts of the system. Okay, so JVM restricts it basically. So, and coming to performance, JVM's performance has improved over time. It's much faster now. And what Java has done is it has added a uh, I mean Java just-in-time compiler. And what just-in-time compiler does is it compiles your bytecode to native code, like your C compiler does, right? It converts the C program to executable code. So your just-in-time compiler also does a similar thing, although we are not converting the entire bytecode, we are just converting some parts of it which we think can gain from this native code thing. The key thing to note is that even this part which is converted to native code, this part also runs in JVM. So still we are using JVM. In I think in in Java IC 9 they have added ahead of time compiler. I'm not going to talk about it much at this point because it's more like experimental thing. They are just trying to pre-compile uh, the bytecode to native code, uh, and instead of the approach with just-in-time compiler follows. So I hope you get some idea out of this. I mean, a short history of Java, what problem it solves, how JVM solves the portability issue and all. I'll try to come up with more videos to explain other aspects of Java. It's pretty huge. The Java platform is pretty huge, so it'll take some time to prepare those stuff. But hope you got some idea out of this. Okay, thanks.